Number 27. A speedboat increases its speed uniformly from 200 meters seconds to 30 meters per second in a distance of 200 meters. Find A, the magnitude of its acceleration, and B, the time it takes the boat to travel the 200-meter distance. So first, for this problem, since it's a one-dimensional motion problem, we're gonna label all the givens first. So we have the initial velocity, final velocity, acceleration, time, and displacement. Since it says increases its speed uniformly from 20 meters per second, we know that the initial velocity is 20 meters per second. For the final velocity, we know that it's 30 because it says 20 meters per second to 30 meters per second. Since we're trying to find acceleration, we don't know the acceleration. Also, we don't know the time either. For the displacement though, we know that is 200 meters. And the picture looks like this, where it starts from 20 meters per second and ends 30 meters per second, and the distance is 200 meters in the positive direction. So for this problem, since we're trying to find acceleration and we don't know the time, we're going to use this equation, since we don't know the time and we're trying to find acceleration. So the equation is v final squared equals v initial squared plus 2a displacement. So we're going to plug it in now. V final equals 20 meter per second squared equals v final equals 30 meters per second squared equals v initial, which equals 20 meters per second squared, plus 2a displacement. Now we're going to try to solve for a. This is meters. So 30 times 30 to the second power is 900 equals 400 plus 400a. We're going to solve for a, so we're going to subtract 400 on each side, which gives us 500 equals 400a. Then a equals 1.25. And the unit for acceleration is always meter per second squared. In the answer in the textbook, it says 1.3, so we're going to round it up. The 5, then we get 1.3 meter per second squared. That is the acceleration, and that is the answer for A. For B, we're going to try to find time it takes the boat to travel the 200-meter distance. So we're going to use the givens again. Then we don't know the time, and we got the acceleration, but we're not going to use the acceleration. So we're going to use this equation right here. The second equation, which doesn't need a, and we're going to try solve for t. So the equation is delta x equals half vi plus vf and times by time. So we're going to try to solve for displacement, time. So the displacement is 200 meters equals 1/2 initial velocity is 20 meters plus final velocity is 30 meters and the time. So if we simplify, we get 200 equals, this is 50 divided by 2, which equals 25 t. If we do 200 divided by 25, we should get t equals 8, and the t is in seconds, so we get 8 seconds. 맞던지네.